Okay, I'm going to take you through how to do an alkalinity titration calculation based on the alkalinity titration data you're going to be collecting in class to keep track of the project treatments. So to begin, you should be looking at a spreadsheet of data from a titration like you see here in Google Docs. Just to briefly remind you of the different things that we have here in the first column, you should have something like salinity. This will be salinity as measured from the vernier salinity probe. We also have concentration of the hydrochloric acid titrant. To find that, again, just to remind you, we're using a BDH titrant from VWR. To find the actual amount of that, look on the bottle, find the lot number on there, and then we can go into us.vwr.com. Once you are there, you search for BDH HCl 0.1N, and it should be the first result here. Go ahead and click on that, and then go down until you find the 1 liter poly bottle. That's what we are purchasing, and you go click on certificates, and then in here type in the lot number. The ones that we're using right now, I think I found the lot number of 16H165005. Hit go, and then that will bring you into this page. You can click on certificate of analysis, and down here, specifically right down here under measured values next to normality, it'll give you the actual measured normality down to 4 decimal places. So 0.1001 normal, or more molarity, and so that is what goes in here for our concentration. Next up, we have the pH tris. This is a buffer that we put the probe in to begin the titration, and just to get a good kind of calibration point. Ideally, we'd like it to be very, very close to the pH of the seawater that we're titrating. But in this case, pH 7 is going to do for the purposes of this class. So we have it in pH 7 buffer, and we also take the millivoltage at that. Next up, we have the weight of the water that we're titrating, and then these last 3 rows are all the steps in the titration that we did. Again, T is temperature, E is the voltage that we measured, and volume is the volume of hydrochloric acid titrant that we added to it at every step. And so from here, what we're going to do is go back and click on File, and we're going to download this as a comma separated variable file. Click on that, and we go ahead and save that file. Okay, then we can go in R and begin the calculation. Okay, so in R, the first thing that we need to do is make sure that we have the proper package installed to do the alkalinity titration calculation, and that package is ccarb. So go ahead and go into Tools and Install Packages, and then type in SEACARB. If you don't already have it installed, click Enter, and then it will go ahead and install ccarb for you. Give it a few moments while it goes through that process. While it's installing, I'm going to type in, we also need to load that once it has been installed. So we're going to type in library and then ccarb up here. So it's finished installing. Now I should be able to load the library, no problem. Now the function that we're going to use to do the alkalinity titrations is the function AT, and in parentheses. Up here, if you go ahead and type that in, it's going to tell you what the arguments are. So the first argument is the salinity. Then we have the temperature of that we did the titrations at, concentration of the acid. Don't worry about D, that's the density of the titrant. Go ahead and leave that as default of 1. pH tris, E tris, the weight, the E, and the volume, just like what we have in our spreadsheet there. Also, if you ever forget this, you can type AT into the Help tab in RStudio, click Enter, and it should take you right to the help page for that. Okay, but before we do any of this, we need to read that in. So I'm going to call this alk and equals, we need to read in the CSV file. So I'm going to type in read.csv, parentheses, quotation marks. I'm going to hit tab to bring up all the things that are in my working directory, and here we have titration sheet3.csv that we downloaded. So we're going to click on that, Control Enter. Let's take a look at that and see what's in there. So just like we had in the Google Sheets doc, we have column S, column C, pH tris, E tris, weight, T, E, and volume. Okay. So next up, we're going to do the calculation for alkalinity. We type in AT. Again, the first argument here is salinity, so we go S equals alk $S, and because that was only the first, it's only the first element here that we want, all the rest are NAs. What we're going to do is after this, we're going to put in brackets and 1, so that will only give us, if I just run that right there, you'll see that only gives us back the first element, not the entire string. Next up, temperature equals, this one we want the entire string, because again, temperature is, we have a temperature for every step of the way, so we want the entire string. We're going to go alk $T, and then leave it without the bracket 1 because we want the entire string. C equals alk $C. Again, this one's only the first one, so we're going to take bracket 1 there. pH tris equals alk $pH tris. And that's the first element. E tris equals alk $E tris, bracket 1. Take the weight, is the weight that we measured the seawater again, so we're going to go alk weight, bracket 1. Finally, our last two arguments are going to be the voltage that we measured, alk $E, and volume equals alk $volume. Okay. Once you have all of those arguments entered, given it all the information it needs, you go ahead and hit Control Enter, and as you see down here, it calculates our alkalinity, which is this right here. One of the nice things that we could possibly do here is now save this as an object to store it away, essentially, to save for a future calculation, save for a PCO2 calculation. So one of the things that we can do is to only get back the value and not this other, it gives us units and it gives us the name here. We don't really want that. All we want is this value here. We can get that by the very end, typing on a bracket 1 here. So now if I run this entire line again, it only gives us the value. And what we can do is we can store this away in another object, say something like titration or something like that, equals. And now we've made another object called titration that has stored our alkalinity result in there. We can now use that in a future calculation. So that is how you go through a basic alkalinity titration calculation in R. I hope this has been helpful.